Multiplying matrices is a little bit more complicated than is addition and subtraction. To multiply matrices, we have to be sure that they're compatible in size. Now here's what that means. This matrix on the left, you see, is a 2 by 3, and the matrix on the right is a 3 by 3. So to be compatible for multiplication, these two inner numbers have to match. So in this case they do, so we are able to multiply these, and the resulting matrix will be these outer numbers. This will result in a 2 by 3. Then we're going to move on to this element here. Now this element here, this is in row 1, column 2. So I'm going to use row 1 with column 2. I'm going to go over and down component-wise. First and first, second and second, first and first, second and second, third and third. So that's going to look like this. First and first is going to be 2 times 1, plus second and second, 1 times 5, plus third and third, plus 3 times 2. Let's just trace it again. So first and first is 2 times 1, right here. Second and second is 1 times 5, right here. And third is 3 and 2, right here. And then the element in this position here, this is in row 1, column 3. So we're going to use row 1, column 3. So over and down component-wise. It's going to look like this. So 1 and 1. This is going to be 2 times negative 1 plus, and then second times second is going to give us 1 times 3 plus, and then third and third, 3 times 5. Now let's come down here. This element here is in row 2, column 1, right? Row 2, column 1. So we're going to use row 2 and column 1. So over and down component-wise. Now we would like to get the element in this second row, first column, then this second row, second column, then the element in the second row, third column. So let's do it one at a time here. This is the second row, first column. So we're going to use up here, we're going to use the elements in the second row, first column. We're going to multiply and then add. So first of all, we'll get first and first, 4 times 2. So we'll get 4 times 2 plus, now, second and second. So we will get 0 times 4 plus, and then third times third. So that's going to give us 5 times 6. Now let's get the element in second row, second column. So we're going to use second row, second column, right? Over and down. So let's try this. First and first. So we'll get 4 times 1. And then second times second is going to be plus 0 times 5 plus, and then third times third, right? 5 times the 2. So we'll get 5 times 2. Now to get our last component, we see that we're in row 2, column 3. So we're going to use the elements in row 2, column 3 up here. And we're going to go first and first. So this is going to be 4 times negative 1 plus, and then second times second. So this will give us 0 times 2 plus, and then third times third. So that'll give us 5 times 5. And we've got them all. Now just a little bit of arithmetic, and we can finish this up and see what our product is. So with a little bit of arithmetic, I think we can finish this off. What we're going to get is, let's just take a look what we have here. What do we get? We get 4 plus 4 is 8, plus 18 is 26. And then right here, we're going to get 2 plus 5 is 7, plus 6 is 13. And then we're going to get negative 2 plus 3 is 1, plus 15, so we're going to get a 16 there. And then down here, we're going to get 8 plus 0 plus 30. So I think we're looking at 38 here. And then here we're going to get 4 plus 0 is 4, plus 10 is 14. All right, a little bit of arithmetic, well, we can finish this up. So we're going to end with this matrix right here. So from this one, we're going to get, let's just do this, keep track of it. 4 plus 4 is 8, and 8 plus 18 is 26. Over here, we're going to get 2 plus 5 is 7, and 7 plus 6 is 13. And then here, we're going to get negative 2 plus 3, that's a 1, plus 15, so we're at 16 here. Let's go down to our second row. We're going to get 8 plus 0 is 8, plus 30 is 38. Then here, we're going to get 4 plus 0 is 4, plus 10. We're looking at 14 here. And lastly, we are looking at negative 4 plus 0 is negative 4, and negative 4 plus 25 is a 21. And there's our product.